It is often said that mathematics is the language of the universe, and scientists use math to describe physical processes. One important branch of mathematics that we will rely on for much of our problem solving in this course is trigonometry, which studies the relationships between the lengths of the sides and the angles in triangles. There are three trigonometric functions that will be utilized throughout the text. These are the sine, cosine, and tangent functions. We can see how these functions are defined by looking at a figure of a right triangle containing the angle theta. We will let the side opposite the angle theta be denoted as h sub o, and the side adjacent to the angle theta is h sub a. The longest side of the triangle is opposite the 90-degree angle and is called the hypotenuse h. In terms of the angle theta, here are the definitions of the three trigonometric functions. Sine theta equals the opposite side divided by the hypotenuse. Cosine theta equals the side adjacent to the angle theta divided by the hypotenuse. And tangent theta equals the opposite side divided by the adjacent side. Many students find it easy to remember these relationships by memorizing the word SOHCAHTOA. Since the trigonometric functions are ratios of two sides of a triangle, they are unitless numbers. Here's an example involving a simple application of trigonometric functions. On a sunny day, a tall building casts a shadow that is 67.2 meters long. The angle between the sun's rays and the ground is theta equals 50 degrees. Determine the height of the building. We see from the figure that the height of the building and the length of its shadow form the legs of a right triangle, where the height of the building is the side opposite the 50-degree angle, and the length of the shadow is the side adjacent to the angle. To find the height of the building, we can use the tangent function. Recall that tangent theta is equal to the opposite side divided by the adjacent side. Thus, the opposite side, or building height, is equal to the adjacent side times tangent theta. Plugging in the values from the problem, we find the building height is 80.0 meters. The value of the tangent of 50 degrees is found using a calculator. Make sure your calculator is in degree mode and not radian mode. Each of the trigonometric functions depends on three variables, the lengths of two sides and an angle. In our simple example, we solve for the length of one of the sides. However, you will also have problems where the lengths of the two sides are known and you have to solve for the angle. In these cases, you will use the inverse trigonometric functions. They are written in the following way. The first relationship, for example, would read as theta is equal to the inverse sine of the opposite side over the hypotenuse. There is also a relationship that exists among the lengths of three sides of every right triangle. This is known as the Pythagorean theorem, and it will be used quite often in this course. The Pythagorean theorem states the following. The square of the length of the hypotenuse of a right triangle is equal to the sum of the squares of the lengths of the other two sides. While this is not a math course, math is a tool we have to use to solve problems. We want you to be able to focus your efforts on learning physics and not struggling with mathematical hurdles. Therefore, it's important for you to have a solid grasp of the mathematical concepts that will be applied in the course.